question involves sizing electrical cables for a reduced ampacity service, specifically after a fire damaged the original feeders. The original service was a 1600 amp main distribution panel fed by 4 sets of 500 cm copper cables. The owner now requires only 800 amps of power, and the existing breaker is an IT breaker with a 1600 amp frame, a 1000 amp continuous current rating, and dual overcurrent trip with an adjustable time delay pickup. The key question is whether the cables can be sized for 800 amps or if they must be sized for 1000 amp. The answer is that the cables can be sized for 800 amps. This is because the overcurrent protection device, which is the breaker in this case, has a continuous current rating of 1000 amps. This means that the breaker is designed to allow up to 1000 amps to flow through the circuit continuously without tripping. However, the breaker also has a time delay pickup that is adjustable and can be set to trip at 800 amps. This means that if the current exceeds 800 amps for a period of time determined by the time delay setting, the breaker will trip, protecting the circuit from overload. The fundamental principle here is that cables must be sized to handle the maximum current that will flow through them under normal operating conditions. In this scenario, the maximum current is limited to 800 amps by the adjusted time delay pickup setting of the breaker. Therefore, the cables only need to be sized to safely carry 800 amps. To determine the appropriate cable size, one must consult the National Electrical Code, or NEC. The NEC provides tables that specify the ampacity of different types and sizes of conductors based on their insulation type and installation conditions. For example, NEC Table 310.15b16, formerly Table 310.16 in the 2014 NEC edition, provides ampacity ratings for conductors rated 0 through 2000 volts, insulated with various materials, and installed in different configurations such as in free air, in raceway, or direct burial. The specific table to use will depend on the insulation type of the 500 cm copper cables, the method of installation e.g. in conduit underground, and the ambient temperature. It's crucial to ensure that the selected cable size has an ampacity rating equal to or greater than 800 amps after applying any necessary correction or adjustment factors. Correction factors are applied when the ambient temperature is higher than the temperature listed in the ampacity table, as higher temperatures reduce the cable's ability to dissipate heat and therefore lower its ampacity. Adjustment factors are applied when multiple current-carrying conductors are bundled together in a raceway or cable, as the heat generated by each conductor can affect the ampacity of the others. For example, if the 500 cm copper cables have THHN insulation and are installed in a raceway underground, Table 310.15b16 might show an ampacity of around 380 amps for each cable at an ambient temperature of 30 degrees Celsius. Since there are 4 sets of cables in parallel, each set will carry 200 amps, 800 amps divided by 4. This means that 500 cm THHN cables would be suitable in this scenario, assuming no additional adjustment or correction factors applied that would reduce their ampacity below 200 amps per cable. However, it's essential to verify this with the appropriate NEC table and consider all applicable factors. In addition to sizing the cables for the continuous load of 800 amps, it's also important to consider the interrupting rating of the breaker. The interrupting rating is the maximum fault current the breaker can safely interrupt without being damaged. The available fault current to the main distribution panel must be determined through a fault current study. The breaker's interrupting rating must be equal to or greater than the calculated available fault current. If the available fault current exceeds the breaker's interrupting rating, the breaker could fail to interrupt the fault current safely, leading to equipment damage, fire, or personal injury. The selection of appropriate overcurrent protection is governed by NEC Article 240. This article provides detailed requirements for the protection of conductors and equipment against overcurrents. Section 240.4 specifies the requirements for overcurrent protection of conductors, stating that conductors must be protected against overcurrent in accordance with their ampacities. However, there are exceptions to this rule, such as the next highest standard overcurrent device rating rule in section 240.4b, which allows the use of a higher rated overcurrent device in certain situations where the conductor ampacity does not correspond to a standard overcurrent device rating. In this case, since the cables are being sized for 800 amps, a standard 800 amp breaker would be the ideal choice. However, since the existing breaker is a 1000 amp breaker with an adjustable trip setting, it can be used as long as the trip setting is adjusted to 800 amps and the cables are adequately protected at that setting. It's also important to ensure that the existing breaker is in good working condition and has been properly maintained. Breakers can degrade over time, especially after being subjected to a fire. Therefore, it's recommended to have the breaker inspected and tested by a qualified electrician to ensure that it is functioning properly and will trip at the set point of 800 amps. Furthermore, the connections at the breaker and the main distribution panel must be carefully inspected and tightened to ensure that they are making good electrical contact. Loose connections can cause overheating and voltage drop, which can lead to equipment failure and fires. The NEC requires that all electrical connections be made in a manner that ensures a permanent and reliable connection. In summary, when reducing the ampacity of a service after a fire, the cables can be sized for the new reduced ampacity as long as the overcurrent protection device is properly adjusted to protect the cables at their new ampacity rating. It is imperative to consult the NEC, specifically Article 240 and Table 310.15b16, to determine the appropriate cable size and ensure that all applicable correction and adjustment factors are taken into account. Additionally, the interrupting rating of the breaker must be verified to be adequate for the available fault current, and the breaker and its connections must be inspected and tested to ensure proper operation. Engaging a qualified electrician is crucial for performing these tasks safely and in compliance with the NEC and local electrical codes. The installation must adhere to the NEC requirements for cable support and protection. This includes using appropriate conduit or cable trays to protect the cables from physical damage and ensuring that the cables are properly supported and secured to prevent strain on the connections. The NEC also specifies the minimum bending radius for cables, which must be adhered to in order to avoid damaging the cable insulation. Proper grounding and bonding are also essential for electrical safety. The grounding system must be properly installed and maintained to provide a low impedance path for fault current to return to the source, which will cause the overcurrent protection device to trip and de-energize the circuit. Bonding is the process of connecting all metal parts of the electrical system together to create an electrically conductive path. This helps to prevent voltage differences between different parts of the system, which can create a shock hazard. The NEC provides detailed requirements for grounding and bonding in Article 250. Finally, it's important to document all changes made to the electrical system, including the new cable size, the adjusted breaker setting, and the results of any inspections or tests. This documentation should be kept in a safe place and made available to anyone who needs to work on the electrical system in the future. This documentation should include a single line diagram showing the electrical distribution system and the ratings of all major components. It should also include a load calculation to verify that the new service capacity is adequate for the owner's needs. This ensures that the electrical system is safe, reliable, and in compliance with all applicable codes and standards. Remember, electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Always follow safe work practices and use appropriate personal protective equipment when working on electrical systems.